So hello everyone, today we are going to study about finite automata with output. We have already done what is DFA, NFA but with each of them there is no output attached with each state. So in this lecture we are going to study about what is exactly, how does finite automata with output work. So as I have said, with output, as the name suggests, every state will return an output and it will go around. Okay, so finite automata with output and without output. For finite automata without output, we have already done about what is NFA. Okay, so what is NFA, what is DFA? So we have studied about this. Next, we'll be studying about the Mealy machine and the Mealy machine. So for Mealy machine, every state will be having its own output attached. Like for, if I say, like for state Q1, there will be an output 1 attached with it, and state Q1, Q0 will be have one output, and state Q1 will be having 2 outputs. So similarly, whatever output we are getting, each state will be attached. And with Mealy machine, we have input and output attached with each. Okay, so we'll study more about this further. So Mealy machine is a finite state machine where the output is associated with states. As I said, output is associated with the states. So like Q is a finite state, set of states, sigma is a finite set of symbols called the input alphabets. Then O is the output alphabets that I've said that every state is associated with one of the other output. And then transition function, and X is the output transition function. That means whatever, like if I say over here, like what state is returning what output. Okay, this is the transition function of for what we are saying. And the original transition function, that it is what input, which state is taking what input, and it is going to another state. So Mealy machine is a finite state machine where the output is associated with the present state as well as the present input. Okay, so as I say, like if I go about Q0, okay, so if we are giving an input 1 and it is returning an output 1 and it is reaching to Q1. Okay, so what we are saying over here is that we are getting an input and output in the current state only. In Mealy machine, what was happening? Let's see. In Mealy machine, it was happening that there is a state Q0 which is taking an input 1, okay, and it is returning to Q1. So Q1 has its own output 0, and let's suppose Q0 has its own output 1. So everywhere Q0 will be called, the output will be 1, and everywhere where Q1 will be called, the output will be 0. So design of a Mealy machine. So design of a Mealy machine, what we are talking about, the construct a Mealy machine that prints A whenever the sequence is 0, 1 is encountered in any input binary string, and then convert it into Mealy machine. Now what we are doing is we are trying to understand how do we create a Mealy machine. Okay, so what the question saying, prints A wherever the sequence 0, 1 is encountered. So that means whenever we get the string 0, 1, we'll give the output as A. Okay, so that means whatever state gives 0, 1, that state will be having its output as A. Else we can give any other output, that is B, that we are seeing over here. Okay, so like if we move further, like C is returning A. Why? Because 0 and 1 is being counted over here. Okay, 0 and 1 is counted, and hence we are reaching to the point C, the state C, which is returning A as output. And in any case, like if we see this 0 and 1, here 1, 0, 1 again, 0 multiple times, but every time we are getting, so in this DFA, wherever we are getting 0, 1 as input, or like whenever 0, 1 is encountered, it is reaching state C, and the state C is having its output as A. Okay, so I hope this is clear to you. Now let's see how do we transition of a table of a Mealy machine is created. Now if we can see, every state A, B and C. C has its output A and other are having output B. And we have the inputs, the transition tables. That transition table is in front of you. Now what we are going to do, we are going to convert this exact table into the Mealy machine. So as per we know, how do we create it? So there is a small understanding that we'll take up, like what is Mealy machine. Mealy machine takes, like if we talk about A, okay, A has the output B. It is taking 0 as input and it is reaching B, and B's output is B. Okay, so if we go through, so what we have to do over here is we have to send the input and output in the same way. So if we do it this way, A in going to B is taking 0 as input and returning B as output. That means we are creating the Mealy machine, and whatever state it is reaching to, we are creating the output of that particular state. Okay, so this is what we are going to do in our Mealy machine. Design a Mealy machine. Construct a Mealy machine that takes set of all strings over sigma 0, 1 and produces A as output if ends with 1, 0, or produces B as output if input ends with 1, 1, otherwise C. Now let's create a Mealy machine for this. Now Mealy machine, what does Mealy machine means? We'll have the input and output in the same array. So let's draw it. We have Q0, okay, set of that produces A as output if input ends with 1, 0. So let's create 1, Q1, Q2. Okay, so wherever we are getting 1, 0, we will return B as output. Okay, and it will be it will be A as output wherever we are returning, we are getting 1, 0, and it returns B as output if input ends with 1, 1. So we take it as 1, Q3. Okay, so as we see, whenever we have 1, 0 and otherwise it is returning C. Okay, so if we go about, now we are getting 0, 1. Now what we'll get? If I'll get 0, I'll get 0 with C. Okay, why? Because we are reaching to this particular, now there is no final state in such machines. We are getting output, and that is what we have to take care for most. Okay, so if you are going about this way, like 1, 0, that Q0, Q1 and Q2, we are getting 1, 0. So here Q2 takes 1, 0, Q3 takes 1, 1. Okay, so we have 0, 1 satisfied, 1, 0 satisfied. We have 1 going to it, satisfied. Now with Q3, if I go for Q3, what do we do? Q3, take it as 0, it will return C because we are not getting anything, and we can give it 1. Okay, so 1, 0 will return what? The 1, 0 will return A, and then this 0, 0 would definitely return C only. So we have finally conquered all the situations that will, or all the possibilities that can happen around this. So we can see this is the input and this is the output. Next, so how does transition table takes place? Okay, so state, like we go through what we are doing, Q0, Q1, Q2 and Q3. Okay. So what we are trying to draw, like with input 1, we are reaching to Q1. Okay. So with input 0, we are getting 0, C and Q3. So Q3 and C. With 1, we are getting Q1 and C. Q1 and C. Similarly, with Q1, with 0, we are getting Q2. But the output here is what? A. Okay. With 1, what we are getting? Output as B. And what state? Q3 state. Okay. Similarly, Q2, what does Q2 return? Now, here we don't know, now we are not drawn anything for Q2. Now, we are again return 1A as per the question says, and for 0, or C, here also it will be C. Okay, fulfilled. So again we'll write both the output as C. With 0 it's Q0 and with 1 it's Q1. So with 0 it's Q0, with 1 it's Q. Okay, and then finally Q3. What is Q3 returning? Q3 with 0 input takes Q2 and returns C. Okay, and then with Q3 it goes to Q1 and gives, what does it give when it goes to 1? C. Okay, so this is how we draw our transition table for the Mealy machine. Now construct a finite state machine with output that takes all the strings over AB and counts the number of occurrence of the substring A, B, B. So we'll draw a simple DFA over here. Q0, Q1, Q2, and then Q3. Okay, so what we are trying to do? A, B, B. Now we have to construct a finite state machine with output. Now here we can draw a Mealy machine also or a Moore machine also. Okay, so we'll draw a Moore machine for now. So if it is saying construct a with takes output that takes all the set of all strings and counts the number of increase of a substring A, B, B. That means instead of making a final state, we can make a single output for it. So wherever we are getting A, B, B, that is what is not, this is normally the final state. So we are drawing it as 1 and we are giving the output as 0 and 0. Okay, now as I said, we'll draw a DFA. So what we'll do, here is no, there's no need to draw a dead state. So okay, so we give A to this and B further. Okay, so we are getting A, B, B and then again B, A, B, B. Okay, again we'll have to give B to this state. So what we'll try to do, because we have to get, so we'll give a self loop to this. Okay, and similarly over here, what we'll do, we'll give a self loop of A over here. So we'll get A, B, B at last, similarly A, B, B, and over here if we'll say we are getting. So what we have done, wherever, now for Q0 also the output will be 0. So wherever we are moving further, like Q0, Q1, Q2 or Q3, we are getting the same thing. Okay, then construct a Mealy machine that takes a set of strings over a comma b as input and prints 1 as output for every occurrence of ab as a substring. So 1 prints 1 means this is the output. Now ab as a substring means if we draw a regular, like if we want to know what are the like possible things, that ab has to be there, and in the starting and at the end it can be anything. So we can draw it this way. Okay, so we give it AB as a substring, just hold on, I think I draw one extra state. Okay, and further a comma b. Okay, so AB has to be there, and in the start and at the end it can go to anything. Now we are drawing Q0, Q1 and Q2. So this was the NFA or the finite machine that we had drawn. So what we can do is we can draw a particular like AB as a substring. For this we have drawn this. Now what we will do, we will draw we will make each and everything for like will make the output run with it. So what it is saying, it should print AB. So wherever we are getting B, it has to come 0. Now we'll again try to redraw it, and we'll try to make all the possible things that can happen over here. Now how do we draw that? Q0. Now when it goes to A, okay, so now this is the particular machine that we have drawn. Now when we are getting A, it will return 0, but when we are getting AB, it will return 1. Similarly, when we are getting 0, it will return 0 over here for the same we are talking about. Now what it is? B, AB, and this will be A. Okay, so it will again return, what it will return? It will return 0, and then this will also return 0. This B will return 0, this will also return 0. Okay, and then finally we have the final answer among us. So what we are seeing, like B, 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 A, B is being accepted. B, anywhere you go, so wherever A, B is occurred, we have got 1 as output. Okay, so we'll talk about the differences between Mealy machine and Moore machine. So output depends upon the present state and the present input. So we have to take care of this because we are going to do conversions further, which will be very important. So the output depends upon the present state and the present input, and output depends only upon the present state. How do we differentiate this? We differentiate it by this way, that output depends upon the present state. Present state means whatever input we are talking about, okay, we have the output along with it. Okay, but over here Moore machine, every state is having an output associated with it. Okay. Similarly, it has fewer states, and next it has more states. The value of the output function is a function of the transitions and the changes when the input logic on the present state is done. The value of the output function. Okay. So what it is, when the input logic on the present state is done. What that means, whenever the input changes, the output also changes. Okay. And here the value of the output function is a function of the current state and changes at the clock edges whenever state changes occur. Okay. So what happens over here, whenever we are getting an output at the final state, what we talk about the final state, only there the output will be incurred. Finally, Mealy machine react faster to inputs, and they generally react 1 clock cycle later. Now what does this mean? Mostly Mealy machines and Moore machines, Mealy machine will be having Mealy machine will be having less states, and Moore machine will be having an extra state. Okay, so whenever you convert a Mealy machine to a Moore machine, so the states get incremented by 1 mostly. Okay, so whenever we are trying to convert a Mealy machine to a Moore machine, the states increases. So that's why react 1 clock cycle later. Okay, and for Mealy machine, the states normally are the same, or it can even decrease. Okay. Now, what are the applications of Moore and Mealy machines? Now, a Moore machine is used as a write enable in SRAM because of its speed. Okay, so Moore machine means every state is having its own output. So how can we say it as a write enable in SRAM? Because what we say, like write enable in SRAM. So whatever RAM works upon, the state of it will react upon it accordingly. Okay, an elevator is a good example of Moore machine. That means if you are inputting while you go into the elevator, whenever you enter an elevator and you press 5, okay, you press the input 5. So what happens? Elevator is a good example of a Moore machine. So every state is having an output, as we say. So whenever we go to that, whenever we input 5, we reach to that state. State means whatever floor we are going. So that is whenever you reach that output, only then your lift will stop. Okay. So like if you have pressed 5 it will take as input and it will reach further. Then Mealy machine are used in processors. Your CPU, your any processor, your processor chips all use Mealy machine. Mealy machine, why? Because whatever input you give, instantly they return the output to it. And finally, the Mealy machines are explicitly used in cipher machines. For cipher machines, Mealy machine are helpful because of the obvious facts where input and output are correlated or interrelated to each other, and whatever input is getting, whenever instant reaction are required for every input, we return it by having the cipher machines using what? Mealy machine. So if I say whenever I need an instant output for every state, so what we take over here, instant output for every state, we use Mealy machine. And if we need each and every state to give an output like this, so we use Moore machine, where each and every state has its own output. Okay, so that's it for the lecture. Now in next lecture we will see how do we convert a Mealy machine to a Moore machine and vice versa. Thank you.